Today's learning intention is Introduction to Integration. Our National 5 essential skills are: we need to be able to simplify surds and indices and also be able to work efficiently with fractions and integers. So let's get started. Introduction of integration. Integration is the opposite of differentiation, just like divide is the opposite of multiplying. They are inverse operations. Example, so if f dash of x equals 8x, well, what is the function f of x? So in your head you're now trying to undo the differentiation. Well, f of x could be 4x squared plus 1. If we differentiate 4x squared we get 8x. If we differentiate the constant 1, then the constant vanishes. Well, wait a minute then, if the constant vanishes, then f of x could also equal 4x squared minus 3. Or it could equal any function 4x squared plus some constant, and we call that constant c. So we have a family of quadratics here, 4x squared. They all have a different y-intercept. So which one is it going to be? Well, the answer is we don't know. So we have to put c in, and we call c the constant of integration. Right, what notation do we use for integration? Well, you can see here we've got this funny long S symbol. Okay, now we say the integral of 8x dx equals 4x squared plus c. Or how we say that in English is the integral of 8x with respect to x. So the dx at the end means that we're integrating with respect to the variable x. In this notation, the long S, we call the Leibniz notation after the man who came about, who invented this notation. So, how do we integrate? Well, as we said, it's the opposite of differentiation. When we differentiate, we multiply by the power and subtract 1 from the power. So let's put that in the opposite direction. Okay, let's do the inverse operations. So we're going to integrate, we're going to add 1 to the power and then divide by the new power. And here it's written out for you. This is how it's written in the textbook. So we've got the integral of x to the power n with respect to x equals, so it's x to the power n plus 1 divided by the new power n plus 1 plus c, the constant of integration. Key steps then. We need to raise the power by 1, divide by the new power, and always remember to add the constant of integration. Special points to note then. Note number 1, the integral of x with respect to x. Now that's x to the power 1, remember, although there's a missing power, it's x to the power 1. So that's easy then. Add 1 onto the power to get a 2 and divide by the new power. We have got a half, it's a half x squared plus the constant c. Point 2. Well, what happens if I try to integrate a number, a constant? In this example it's the number 15. So if I integrate 15 with respect to x, how does that work? There isn't an x. Well, you can think about it as actually having an x to the power 0, because we know that x to the power 0 equals 1. Now, if we do that, then, okay, we add 1 onto the power and divide by the new power. So we've really got x to the power 1 divided by 1, and that gives us 15x plus c. So when we differentiate a constant, the constant vanishes. However, when we integrate a constant, we actually, it then becomes that number with an x next to it, so it's 15x. Right, example 1. Integrate the following. Let's start with example A. So example A says f of x equals x cubed. So at the bottom here we have the key steps. Raise the power by 1, divide by the new power, and add a constant of integration c. Remember the note-taking symbol here, so you're writing this down into your notes. So if f of x equals x cubed, then the integral of x cubed with respect to x equals add 1 onto the power, x to the power 3 plus 1, and divide by the new power 3 plus 1. So that gives us x to the power 4 divided by 4 plus c. Now you could write that if you wanted as a quarter x to the power 4 plus c. Or you can leave it like a fraction as shown. That you have to be good at switching between the two ways, because the textbooks and past papers will either write a quarter x to the power 4 or x to the power 4 divided by 4. Right, example B, I've got y equals the square root of x. Now, just like we had to prepare to differentiate, we also have to prepare to integrate. I'm going to have to write this now as the integral of x to the power a half with respect to x. So I change the square root sign into a fractional index. Now it's easy. Okay, I'm now going to raise the power by 1, x to the power a half plus 1, and then divide by the new power a half plus 1. So a half plus 1 is just 1 and a half. It's x to the power 3 over 2 divided by 3 over 2. Now watch, we're now having to divide by fractions. So when you divide by a fraction, you flip it upside down and multiply. So now we've got 2/3 x to the power 3 over 2. Now you can either have the 2/3 at the sides, or you're going to have 2x to the power 3 over 2 divided by 3 as shown. Right, example C, y equals 1 over x cubed. Again, we need to prepare this before we can integrate. So we've got integral of x to the power negative 3 with respect to x. Now it's easy just to raise the power by 1, divide by the new power, and add the constant of integration. So I've got x to the power minus 3 plus 1 and divided by minus 3 plus 1. So I've got x to the power minus 2 divided by negative 2. Now I'm going to have to change that back. It's good practice to change that back into a positive index, because sometimes we're going to have to go in and evaluate our integrals. So that's the same as minus 1 over 2x squared plus the constant of integration c. Now part B, it popped up again. We have then changing x 2x to the power 3 over 2 to 2 times the square root of x cubed. So again, it's just being able to go from fractional indices into surds, or going from negative indices and making them positive indices, so that we can then evaluate our integrals for later on. Right, let's get a bit more complicated and try example 2. Right, for example 2, we're going to be looking at integrating terms with coefficients. So what do I mean by that? Well, a coefficient is the number before the variable x. So here it's written down, if I'm trying to integrate a times x to the power n with respect to x, well, remember, we're only really integrating with respect to x, so the a can come out. Okay, so we just leave it alone, and then we integrate the variable x to the power n. And that gives us a times x to the power n plus 1 divided by n plus 1 plus c. So basically, integrate the variable as usual and then multiply by the coefficient. Always simplify your answer as far as possible, leaving positive indices. That means we can evaluate our integral later on. And remembering our key steps, raise the power by 1, divide by the new power. Now you have to multiply by any coefficient we have, and remember to add your constant of integration. Example 2, integrate the following. We've got a function f of x equals 5x. Example 2, integrate the following examples. Part A, if f of x equals 5x cubed, then the integral of 5x cubed with respect to x equals 5 times, so it's x to the power 3 plus 1 divided by the new power 3 plus 1. That's 5x to the power 4 divided by 4 plus the constant of integration c. Part B, y equals, that's a quarter x to the power half. That's the integral of a quarter x to the power half with respect to x. That's a quarter times x to the power, so a half plus 1 is 1 1/2, that's 3 over 2, and we're dividing by a fraction, we're dividing by 3 over 2. So that equals 1/4 times 2x to the power 3 over 2 divided by 3, and then simplifying that together, we get 2x to the power 3 over 2 divided by 12, and the 2 and the 12 can be simplified, and we're going to have x to the power 3 over 2 divided by 6, plus the constant of integration c. And here I've taken your fractional index and put it back into third form. So x to the power 3 over 2 is the same as the square root of x cubed. Example C, y equals 3 over 2 x to the power 5. Now again we have to prepare to integrate. That's the integral of 3 over 2 times x to the power minus 5 with respect to x. So the integral equals 3 over 2 times x to the power minus 4 divided by minus 4. Now we have to simplify, and that gives us negative 3 over 8 x to the power negative 4, and back into a positive index, that equals minus 3 over 8 x to the power 4 plus c. Key steps, remember, are raise the power by 1, divide by the new power, multiply by any coefficient, and add your constant of integration c. Right, now time to try these examples on your own. When you've finished them in your jotter, you can press pause just now. When you've finished them in your jotter, come back, start the video again, and you can mark your own work. Good luck! Right, hope that was easy enough. Here are the answers. Now remember, if you've not got the answers correct, can you try and find from your working where your mistake is? Okay? If not, then please speak to your teacher tomorrow. Right, take a little moment to self-assess your progress. Red, amber or green. How did you do today with this lesson? If you would like extra practice, try page 169, exercise 9G, and then move on to page 170, exercise 9H in your Heinemann Maths book. So what have we learned today? Well, you've learned how to integrate. Integration is the inverse of differentiation. Our key steps are to raise the power by 1, divide by the new power, multiply by any coefficient, and add the constant of integration plus c.